Hello friends, next topic which is going to be applicable for the Starfield normal or Starfield vertical, right? When a tachometer is fitted with extra lens, that setup is called the Anallactic lens. See the optical diagram of the analytic lens. This figure shows this is the eyepiece end, objective lens end, and one more lens, convex lens, is introduced in between the eyepiece end, that is the stadia intercept I, and to the objective lens one more lens is attached. What is the advantage of it? It again reduces the, say, the focal length and the distance, say the small distance impact in the stadia readings, right? So which reduces the constant, additive constant becomes 0 and the multiplicative constant k become 100, right? So this is the manufacturing setup. Predominantly when the instrument is fitted with analytic lens, the constant becomes k is equal to 0, k is equal to 100 and c is equal to 0, right? So in the problem, if they mention like this, you can take it as a granted that instrument is fitted with analytic lens, then you can assume k is equal to 100 and c is equal to 0, right? So how it happens, it is a theory, but you should remember there is a one more new lens get introduced in between the eyepiece end to the objective lens, right? So the incoming ray which has to fall and from here it has to move get again refocused at some other point, say f1. From that it touches the new lens and it get focused exactly to the eyepiece. So the required eye intercept get changed to the new, right? So this is the thing, so that the calculation of distance becomes very easy. Already distance formula you know, d is equal to k s plus c. Here the c becomes 0, so the distance becomes d is equal to k into s, right? So these are the things you have to remember. Now we see the problem. Before going to see the problem, these are the paths available. Principal focus of the analytic lens. N is center of the instrument. Small d is the distance between O and the vertical axis of the instrument. D, distance between vertical axis of the instrument and the staff. M is equal to distance between O and actual image AB. F1, F2 are the conjugative focal lengths of the objective glass. F is the actual focal length of the objective glass. F dash is the focal length of the new analytic lens, and I is the image size AB when analytic lens is provided, and I dash is the image size when analytic lens is not provided, right? So M minus N and F2 minus N becomes the conjugative focal lengths of the analytic lens. Say this is the M minus N, the distance becomes the new conjugative focal length, right? And here F2 minus again N, again it gives the focal length when the analytic lens is not provided, right? These are the terms you have to remember, right? Next, consider this problem. Two sets of tachometric readings were taken from an instrument, station A RLS 100 to a staff station B as shown below, right? The two positions two set of readings were taken from P and Q. In the position of P, the multiplicative constant and the additive constant is 100 and 0.3, and in the position of Q it is 95 and 0.45, and the height of instrument at both the position is 1.4 meter and 1.45. From this position, this staff was focused is here, it is vertical and here it is normal, and the readings, instrument at P, instrument station at A, staff station at B, and the vertical angle is 5 degree 44 minutes, staff reading is given, and the second instrument which is set at over the same station A and focus on the staff station B for the same angle, and but the staff is held normal. What will be the reading? So this is the reverse process. So determine the distance between the instrument station and the staff station, RL of the staff station B, stadia readings with instrument Q. So you try to remember, in a particular same point we are using two different equipment, and we are reading the staff reading on the same station B from A, but from first portion the staff is held vertical, in the second the staff is held normal to the line of sight, and here the vertical angle given is 5 degree 44 minutes, so it is predominantly elevation, right? So there is no negative symbol, so it is in elevation side, right? From the given data, instrument P at station A, first condition, and the staff is held vertical at B, so the S you can calculate. How you can calculate? Top minus bottom, you get the S, right? Top minus bottom, theta is given, so 2 theta we have calculated. So the distance formula you know for the inclined line of sight is Ks cos square theta plus C cos theta. So if you substitute all the values, you get the distance AB. And the vertical distance formula you know, Ks sin 2 theta by 2 plus C sin theta. Substitute all the values, you will get the value 7.038 meter. RL of B is equal to RL of A plus height of instrument plus V minus H. Instead of R, they are using their own notation H. So RL of A is given, height of instrument at that position is given, V you have calculated, minus H. What is H here? 1.44, that is a center reading. See, the center reading is 1.44. You have obtained the RL of B. From the second instrument, instrument Q at station A and the staff held normal at B, from this condition whether the distance going to change? No. And the RL of the particular point going to change? No. These are the clue for determining the staff reading or the stadia reading when the staff is held normal, right? So when the staff is held normal, the formula you know, distance equal to Ks plus C into cos theta plus H sin theta. So you K, it was given in the problem, but you don't know the S since we are not having the stadia reading itself. So S unknown, C you know, cos theta, theta you know, H we are not having the reading, so all the reading, but the distance you have already calculated, it is 70.095. Now you have obtained an equation with respect to in terms of S plus H, which is equal to, so either any one we can focus, either we can focus S or we can focus H, no issue, but both the reading we have to determine for calculating the readings. And again we are known equation for V is equal to Ks plus C sin theta. In this also the S is unknown, we substitute the remaining values, right? The RL of B is equal to already we have calculated R log B. With respect to second instrument, R log A plus height of instrument plus V minus H cos theta. So we substitute R log A, height of instrument, V, this term we have to substitute, minus H cos theta you can substitute, but R log B already we have calculated. This gives one more equation in terms of S and H. We convert into H is equal to, already we are having one more equation, H is equal to. Solving both the equation, you are able to get the S, that is the stadia staff intercept value 0.735244. Therefore H is equal to, if you substitute either equation 1 or 2, you will get the value of H is equal to 1.4819. So we required the H becomes the middle reading, right? Now we have to require top and the bottom. The upper stadia reading is equal to 1.4919 minus, what is this 0. Staff stadia intercept is full top minus bottom. The half we have to subtract, you will get 1.1143, and if you add, you will get the top reading. This is the bottom reading and this is the middle reading, right? But here see, upper stadia wire, but in our eyepiece it look like the bottom, and in the stadia it will be the top. So the term here uses upper stadia wire, which denotes the lower reading. Lower stadia wire reading denotes the upper reading, right? So this is the way you can calculate. This way all problem also can be asked, right? And we will see one more problem. A tachometer is fitted with an analytic lens. It was given this analytic lens, so the constant are 100 and 0. The readings corresponding to the crosswire on a star field vertical on a point B was 2.295 meter when sighted from A. If the vertical angle was plus 25 degree and the horizontal distance AB was 190 meter, calculate the stadia wire readings and thus show that two intercept intervals are equal. Using these values, calculate the level of B if that of A is 50 meter and the height of instrument is 1.35 meter. So what was asked? Calculate the stadia wire reading and thus show that the two intercepts intervals are equal. So we know distance equal to Ks cos square theta plus C cos theta. Again the C becomes 0 also. So distance is given as 190. K value you can substitute. Staff intercept, since we are not having the reading, S cos square theta, so yes, you can obtain 2.313 meter. This is the vertical held staff. This F, E, G reading we required, and already this center inclined vertical angle is 25 degree and the distance is given. The notations, instead of in the derivation we used beta, here they have used here alpha, right? From the figure, F dash G dash is equal to S cos 25. What is cos 25? Cos 25 is equal to adjacent by hypotenuse. Adjacent is 190 and hypotenuse, and this reading here also it get transferred, right? So F dash G dash can be get, here the theta will be, from that you can get the value S cos 25. What is S? This is fully S, right? So from that you can get S cos 25 is equal to 2.313 cos 25, you will get the value 2.096. A dash E dash, the distance is equal to, sorry, A dash E we required is equal to A dash E dash sec 25. Sec means based on the cos, a dash e dash by cos 25 or sec 25, both are same. So if you substitute that, a dash e dash is 190, sec 25 you substitute, you will get the L distance a dash e is equal to 209.64 meter, and 2 alpha is equal to 2.096 by, what is this 209.694? 2.096 is what? See, already we have obtained f dash g dash is equal to 2.096. It is based on the 2 alpha, right? 2 alpha is equal to opposite by hypotenuse, right? So 1 alpha is equal to the divided thing, you can take that L we have already calculated as 209.64. So 2.096 divided by 209.64. So you obtain the value in minutes. You have to convert to the minutes. 36 minutes. Then alpha is equal to 18 minutes. Why we need to calculate that alpha? Let's see. E dash G. What is E dash G? This distance. E dash G. E dash G point, this distance we are trying to calculate. It is again a right angle triangle, is equal to D tan 25 degree minus alpha. What is why 25 degree minus alpha? Up to this is 25, this alpha to be deducted, since up to this only 25 degree. So we are calculating up to G only, right? So E dash G can be obtained is cos 25 degree minus alpha is equal to adjacent by hypotenuse, but they have used tan, so opposite by adjacent. So E dash G by A dash E dash. E dash G we don't know, so 190 tan 25 degree, alpha you have calculated, so you can obtain 88.578 meter. E dash E is equal to, what is E dash E? E dash E, from here up to this distance, if you are calculate, if you subtract both the, you will get the gap. If that gap is same, then you can calculate the EF also. That is the ultimate aim. Again the same trigonometrical principle. Here the alpha is not need to subtract, it is exactly tan 25, so you will get the 88.598. so E dash F is equal to D tan 25 degree plus alpha, E dash F, from E dash F up to the top, right? So you have to add the alpha, right? Then you will get the 88.618 meter. The stadia intercept interval GE, what is GE? The GE we can get, you have already know E dash E minus E dash G. If you substitute that, you will get the GE. Similarly, staff intercept FE, we require this EF or FE. For that, E dash F minus E dash E. Here also the staff intercept is equal. They asked to prove, here it get proved. So S is equal to GE plus FE is equal to 0.04. What we have obtained here, S is 2.314. Here the staff intercept 0.04. So middle crosswire reading is obtained, we have obtained as 2.295. How it is 2.295? This 2.295 have the logic. the V you have calculated, so from that you can directly put that middle reading. From that middle reading, if you add 0.04 and minus 0.04, you will get the stadia reading, right? 2.315, 2.259. So E dash E is equal to V is equal to D tan 25, 88.598. So the R of B is equal to 50 plus 1.35 plus 88.598 V minus H is equal to 137.653. This is the thing they have asked, right? I hope you understand, friends. This is the problem you need to solve and select the proper answer in your quiz, right? The ruins of an old fort exist on a hill. It was required to determine the distance of the fort from the road and the height of its roof above the plinth with a tachymeter. Observations were made on a 4-meter staff held vertical on the entrance gate of the fort and on the roof from the road. Constant of the instrument were 100 and 0. That means analytic lens. From the road, height of instrument, focus over the plinth and focus over the roof. Both the vertical angles are given and the staff readings are given. You have to determine the distance of the fort from the road and the height of its roof above the plinth with a tachometer, right? These are the things you need to think. First, the choice in the quiz will be you have to give me the height of its roof. That is the thing, right? Thank you, friends.